So hi guys, today we look about vectors. Now we can see definition of a vector, that we can say vector is a one which has both magnitude and direction. We can say it has both magnitude and direction. From here, now we can, like example of this, we can say example of vectors there is of that is which has both magnitude and direction. We can say that its displacement or velocity. These two are examples of vectors or vectors quantity. Okay, we can still say that a quantity which has magnitude only is a scalar quantity. Now scalar quantity, okay, this is quantity which has only magnitude but no direction. A vector can be represented by a straight line with an arrow. So let's take, for instance, we can draw here a straight line here with an arrow. We can name this PQ. Now here we can say that we have made it to represent vector. Now let's say we are told to find the modulus of PQ. So the modulus of PQ, it is denoted by PQ. Now this is the modulus of the vectors, that is of the vector PQ. A vector whose modulus is 1 is called unit vector. Now let's look some definition. Unit vector, this is a vector whose modulus is 1. So here we can first divide this paper here. Okay, now a unit vector, this is a vector whose modulus is 1, and whose, now a vector that its modulus is 0 is called null or zero vector. Null stroke 0 vector, this is vector whose modulus is 0. So that is null or 0 vector. Now a vector OR, okay, a vector who is define the position of a relative R from the origin is called position vector. So we can define position vector. This is a vector OR which defines the position of point R. Defines the position of a point R relative to an origin. That we can call it a position vector. Now let's see. Now we have seen that a unit vector is a vector whose modulus is 1, and a null vector is a vector whose modulus is 0, and a position vector is a vector whose vector or which defines the position of a point r relative to origin. Now we can look here something that is addition and subtraction of vectors. This is addition and subtraction of vectors. So we can say that let vector A and B be presented by direct line PQ and QR. So let vector A and vector B be represented by straight line PQ and QR respectively. Now here we can say, we can come and first draw these two vectors, that is the first line and the second line. Now we can say this is PQ, that means this is vector A, and this is QR, this is vector B. So then the directed line PR represents the sum of the AB and is written in the form. Now we can come and draw like this. You know, now if these two are going out, it is like this. We can draw these together. We can draw like this, and this we can call it Q. This is P, and this is R. So we want to find the resultant here. Now this is A and this is B. Now the resultant, now let's call this C. So the resultant vector is A plus B, that is vector A plus vector B. Now we have seen it like this. You just note that this being Q, this is R and this is P. Now this is heading to this A. Now we can call this C, which is equals to vector A plus vector B. So alternatively we can say that let vector A and B be represented by direct line PQ and PQS. So let vector A and vector B be represented by direct line. By direct line, that is still we are going to use PQ, but in this time we use PS respectively. This is respectively. Now here we can come and see that we first draw PS. This is PS, which now this is vector B. Sorry for that. Okay, this is vector B, and we can come and see that we can come and draw this one. This is PQ. This is vector A. Now the resultant is now this one that will come here in the middle. Now this is A plus B. Now it's heading this way. Now we can complete it as a triangle. We can extend this line further like this, and then we can come here and we complete this with dotted line, and this one with dotted line. Now this is vector this. Now then the diagonal P, that is PR of this parallelogram. Now this is a parallelogram. We can come here and say that the diagonal PR. Now in this case that we can call this is R, so that we can see that this is PR, which is our diagonal, and of this parallelogram represent the sum of two vectors, that vectors A plus vectors B. That is like that. Okay, now this we can call it, this is the parallelogram of vectors addition. Now vector addition. Now we have seen that the diagonal PR represents the sum A plus B, which now this is the parallelogram law of vector addition. Okay, let's see now the difference of vectors A, B. Now the difference of vector A, B is like this. Now we can draw. Now I want you to note this. For addition, the arrow are not meeting anywhere. It is from this point heading this way and this point heading this way. Now we can draw the same triangle with the same arrows like this and like this. Now we want to find the difference in vector. That is the, and now these, they are going to meet at the same point. Okay, we are going to have, okay, here we can come and say the difference is, now here is A plus into minus B. Now we are going to see that this is, we can draw this as the resultant here. Can call this A, vector A, and this we can call it vector B. Then this now represent, okay, this, it's heading this way, it is A minus B. Okay, now that we have seen like that, so the triangle law may be extended to cover the sum of it. Now we can come and see that if this is, we can come and call this as A, B, C. Now you can come and see AC is equals to, now AC is equals to AB plus AB plus BC from the right angle triangle rule, but now this is not applicable here. Now you have seen that this is the, now for you to find this, the resultant of this, you are going to take A minus B. Are we together? I hope now that you have understood how these things are. Okay, now this, I think this, it was coming this way, like this. So here the key point to note for addition is this thing you can plot like this, and this you can plot like this, then you find the resultant, which is A plus B here. And then for subtraction, it will be like this. You can draw this way, and then you find the resultant. So for addition, the arrows are meeting somewhere, but for subtraction, the arrows are tend to move from one point away, to spread away from one point. Now here we can come and see the multiplication of vector by a scalar. This is a subtopic of a vector by scalar. Multiplication of a vector by scalar. Now we can say that let A be a real number n. Let vector A and a real number n be given. Now we can say that vector NA is a vector whose modulus is n times the modulus of A. Then vector NA is a vector whose modulus is n times modulus of A. Now it is like this, that for modulus of A it is this, now times n, which it is n, like that. Now we can see that okay, for multiplication we can come and we draw something here which this implies that this is greater than this and this is greater than this. Okay, let's see, look at an example. Given vector A and B, that is, we are told that draw a vector equal to A, 3A plus 2B. Okay, now here we are told in the figure, now this is in the figure. Now this, we can call this A, this is 3A, and this is negative 2A. Now this is addition. It implies that equal to negative 3. Now let us follow this in these steps. It is like this, you come first, you draw 3A, because we are told that 3A, it is now A, which is like this. You can come and draw A, but now it is 3A. Now it is a little bit longer. Now we can call this 3A, and it's a vector, and then we can come and draw 2B. 2B, this one is a little bit longer still. This is 2B, and B is a vector, and then we come and we draw a resultant here, which it is 3A plus 2B. Now having like this, we can see that we have managed to draw a vector that is equal to 3A plus B. Now let's try to draw B, which it is A minus 2B. Okay, we can come and draw this. We can draw this as like this. We can draw this, and then we call this as vector A. Then we can draw this as vector. Can call this as vector 2B. Now this is coming towards away from A, like that, and then we can come and draw this, which now implies that it is A minus 2B. If we give this as PQR, now we can come and see PQ is equals to PR minus RQ, which it is A minus 2B, and these are vectors. Similarly, you can come here and say that PQR, you can come here and say PQ is equals to PR plus RQ is equals to 3A plus 2B. Now by that we are in a position to have shown that we have plotted this one and this one. So now we can come and see an example here. We are given a triangle like that, and we are also given like this, and like this. Let's take for instance that this is A, and this is B, and this is C. Now we are told that the figure ABC, PQRR points, that is PQRR points. Now that this is PQR. Okay, this is P R, that this, in this case, this P, and this is Q, are points on AB, and PQR are points on AB, BC, and CA respectively. Such that now we are given such that AP is equals to a third AB. Now this is AP, this is AP is a third AB. Now this means that this being 1/3, this is 2/3. This being 1/3, this is 2/3. Now we are given that BQ is equals to a quarter BC. Now BQ is a quarter. Now we can come here is 1/4. This is 3/4. BC. Now we can still come, and we know that it's going on which side. We're going to see that, and we are also given that CR is equals to a half CA. Now this is a half, and this is a half. Now we are told that AB is equals to B, and AC is equals to C. Express PQ and PR in terms of B and C. Now this we can come and see that we first want to express that PQ, this PQ, PQ in terms of B and C. Now we can come and see that BC is equals to BA plus AC. BC is BA plus AC. We can use this root that BC is equals to BA plus AC. Now BC, we are starting from B and we want to end up at C. It means that we can pass this root BA plus AC, which is equivalent to negative B, since this is coming this way. This is coming this way. We are given that CA, this now is going this way, and we are also given that AB is B. Now going back, BA is negative B plus now C, which is equivalent to C minus B, and this is our vectors. Now we want to find PQ. PQ is equals to PB plus BQ. Now this is PQ. This is PQ. This now we have to PB plus BQ. Now in this case, our PB is 2/3 of AB. 2/3 of AB, and in this case that our AB is small b. Now this is small b plus a quarter. Now here we are given as a quarter of BC. In this case we are given that BC. Now we have first to find BC. Now here we come and find BC. Oh, we had found it here. So it is 2/3B plus a quarter into C minus B. So it is 2/3B plus a quarter C minus a quarter B. Now this implies it is 2/3 minus a quarter, and this is B plus a quarter C. You can work it out using a calculator if you have one. Now we come and see that 2 over 3 minus 1 over 4. Now we come and find that this is 5 over 12 b plus a quarter c. Now this is our PQ. Now we are told to find PQ and PR. PQ and PR. Now here we can come and say that PR, now we can come back here, PR, now we can come and say it is PA plus AR. Since we want to from here to here, now we can pass PA plus AR. In this case our PA is 1/3 B, 1/3 BA. So it is 1/3 minus B plus a half AC. In this case we are given that AC is, were we given AC? Now we can say this is AC, so is equal to negative 1/3 B plus 1/3 and a half C, since in this case they are given AC is C. So we can say that this is a half C minus 1 over 3 B. Now we conclude that is our, like that. So that was just an example. Now we can come here, we continue and say that we want to